Hey, what's up, folks? This topic from Alex asks us to pick a reduction or an oxidation half reaction that will make a particular galvanic cell work. Now, Alex is going to set up the parameters for the galvanic cell, and it's going to give you one of the half reactions. In this case, we've been given a reduction half reaction, or we've been given a reduction potential for a half reaction that happens at the anode. Okay, so pay attention to what electrode, whether the cathode or the anode, the half reaction that they're specifying takes place at. And we're also told that we need to get at least 0.8 volts of electrical power out of this. Okay, so we should remember that E for the cell, or E0 for the cell, is always going to be E0 for the cathode minus E0 for the anode, where these E0s are the reduction potentials for the half reaction that happens at the cathode, or the reduction potential for whatever happens at the anode. So in this problem, we are given this, and we're asked to determine what acceptable values for E0 the cathode might be. And then we want to pick out, it'll ask us to pick out a half reaction. Now, I like to think of these problems in terms of a picture. So if I could draw a picture for you here, this arrow represents reduction potentials, and it goes from being more negative to being more positive. Okay, so these are E0 values. For a cell, we're going to have an E0 value for whatever happens at the cathode, and we'll have an E0 value for whatever happens at the anode. And the cathode is going to be the more positive one. The anode will always be the more negative one. The difference in voltage between these two is going to be E0 for the cell. Okay, so E0 is represented in this image by that gap between the cathode and the anode. All right, so we're told a couple of things in this problem. We're told that this difference between the cathode and the anode has to be at least 0.8 volts. All right, so it wants 0.8 volts to be that gap. And we're also told that the reduction potential at the anode is 1.33 volts. So if we have 1.33 as our lower limit and a gap of 0.8, then that makes the upper limit have to be 2.13, if I did my mental math correctly. Okay, so a cathode sitting at 2.13 volts, an anode sitting at 1.33 volts, those two things will combine to give us an overall cell voltage of 0.8. Now for this problem, 2.13 is going to be the minimum voltage on the cathode that will do the trick. But anything above that, so anything up in this area, reduction potentials up in here will give E0 for the cell of greater than 0.8 volts. Okay, so those would work for the parameters of this problem. So in other words, 2.13 we could think of as being a minimum potential that the cathode could have. Okay, so let's use this thinking and this diagram to help answer some of the questions here. First is there a minimum standard reduction potential that the cathode needs to have? And the answer is yes, there is. And it asks us what that is. So the minimum potential would be 2.13 volts. Is there a maximum? And the answer is no in that case. Okay, there's no maximum. You can theoretically just keep going until you get to infinite volts. Now it asks us to look up a half reaction in the Alex data tab and write a balance half reaction that would describe it. Okay, so I don't have access to the Alex data tab, but I did look in another textbook and I found that the fluorine half reaction, F2 plus 2 electrons going to 2F minus, does have an E0 that is greater than 2.13. I think that E0 for that is around 2.33 or something like that. So E0, whatever it is going to be greater than 2.13 volts. Okay. Now variations on this, Alex might give you the potential that the cathode is at, and then ask you to figure out what potentials for the anode would be acceptable. And in that case, you might be thinking about reduction potentials that are down in here. So there might be a maximum that is acceptable, and to get actual ones, you would be more and more negative. They'll probably change the voltage that it has to be more than. Some of them were 1, some of them were 0.8, various things like that. So there's lots of different varieties that you might encounter, but I think that this will give you a start on working your way through that. Thank you very much.